When you want to rationalize denominators, what you're doing is you're getting rid of a square root from the denominator of a fraction. So that's the whole idea for doing this. So the idea is if you've got a, for example, if you have denominator is something with the square root of c in it, you're just going to multiply by square root of c over square root of c. So whatever you have on the bottom, just the radical, you'll just multiply by itself, top and bottom. So essentially what you're doing is you're multiplying the original thing by a power of 1 because root c over root c, that essentially is 1 that you're multiplying it by. Let's do that for this problem down here. It says rationalize the denominator. We have 1 over the square root of 19. So what you're going to do on this is we have the 19 is like your c value that we have up here. What you're going to do is you're going to multiply the top and bottom by the square root of 19. Whatever square root is on the bottom, that's what you're going to multiply by. So we're multiplying by a power of 1. Now, when you multiply across the top, across the bottom, and you get square root of 19 across the top. And the bottom, square root of 19 and square root of 19 is going to, so let's do that off to the side over here. Square root of 19 times square root of 19 is square root of 19 squared. But then the square is going to get rid of the radical, and then you just end up with 19. That's the whole reason why you're multiplying by the square root of c, because whenever you do that, you're always going to get the square root to cancel out on the bottom, and so we no longer have that. So that's called rationalizing denominators, is you're getting rid of the radical that is on the bottom. Now, the reason why this whole thing started out in the first place is because initially, before there were calculators, if you're trying to do an operation like this where you have 1 divided by square root of 19, that's very hard to do by hand when you have something like that where you're dividing by a square root. So instead, we did rationalize the denominator, so where now the number you're dividing by is now an integer instead of a radical. And so if you're doing that by hand, that's an easier calculation to do. Of course, now it doesn't matter because we have technology to take care of all this. But this has just been passed down, and that's why we're still talking about this. So mathematics has said that an official way of writing your answer would be if you don't have a radical on the bottom. So we always try and rationalize denominators if we end up with a radical in the denominator. And that's the reason why we're going through all this in the first place. Now let's do another problem like that. We'll do this one here. This is negative on the outside there. So I'll just put the negative on top. Negative 42 over 5 square root of 6. We're going to multiply by the square root of 6 over the square root of 6 here. So now that we have this, we'll multiply across the top, across the bottom. Now, across the top, you get negative 42 square root of 6. Across the bottom, you have 5 times. Essentially, that's going to be square root of 6 squared there that you have. You're multiplying like that. So you'll get negative 42 square root of 6 here. On the bottom, you're going to end up with 5 times 6 because the radical goes away when you square it like that. Okay, so now before I multiply this out and make it 30, I notice that I can do a little reducing here. So the 6 and 42 reduce. So if I divide this by 6, I'm going to get a 7 here. Divide this by 6, we get a 1. So we get negative 7 square root of 6 over 5. And so that would end up being your reduced answer. So you always want to try and reduce on these problems if you can. The negative doesn't matter if you put it on top, on the bottom, or out front. You just need one negative somewhere in your answer. But that would be as far as we can go there. Negative 7 root 6 over 5. Let's do another one of these type. Okay, so we'll do this one here. We have 21 over 4 root 7. So we're going to multiply this by root 7 over root 7. Okay, so square root of 7 over square root of 7. Multiply by. Multiply across the top, we get 21 square root of 7. On the bottom, you get 4 times square root of 7 squared, which means you get 21 radical 7 over 4 times 7. And here's another case where we can reduce. We got a 21 and we have a 7 here. So we'll divide both of these by 7. Divide that by 7, we'll get a 3. Divide this by 7, we get a 1, which means our final answer is going to be 3 radical 7 over 4. There's nothing more we can do to reduce this.